Welcome to Alpha Mathematica. This video will explain about Modi method or UV method. Here is the steps for Modi method. Verify for degeneracy is step 1 and step 2 is setting up of cost matrix for allocated cells and step 3 finding values of UI and VJs and step 4 finding cell evaluations for vacant cells and step 5 checking the sign of cell evaluations. If all are positive, our current solution is optimal. Otherwise, move on to the next step. Step 6, forming loop. Step 7 and 8 will find new allocation. And step 9, check this new allocation for optimality. That is from step 1 to step 5. If we get all net evaluation positive for this new solution, then this new solution is our optimal solution. Otherwise, we have to use from step 1 to 9 again. Okay, so we have to move all these steps repeatedly until we are getting all net evaluations positive. Okay, all net evaluations are positive will indicate that this solution is an optimal solution. Okay, so we are going to use these procedures to get optimal solution for our example. This is our example and we have taken the allocations we got from VAM method. Okay, because I have taken VAM method because comparing all the 5 methods we have used to find the basic solution, VAM method has given most optimal solution. Okay, that's why I have taken the allocation we have got from VAM method. Okay, this is our allocation from VAM method and we have got a transportation cost of 102 rupees. Okay, and here we are starting our Modi method. Okay, step 1 is checking for degeneracy, that is m plus n minus 1 equal to number of allocation. Here m is number of rows and n is number of columns, right? Here we have 3 rows and 4 columns. Okay, so m is number of rows and n is number of columns. So 3 rows plus 4 columns. So m plus n minus 1 equal to 6. Okay, which is equal to number of allocations 1 2 3 4 5 6. Okay, so m plus n minus 1 equals the number of allocations, so that our basic solution is non-degenerate solution. Okay, and what is degenerate solution we will talk about in the next video. Okay, and step 2, setting up of cost matrix only for allocated cells. Okay, so we have allocations for these cells. Okay, so we are forming the cost matrix for allocated cells. Okay, so we have taken cost values only for the allocated cells. Okay, this is step 2. And what is step 3? Putting values u1 u2 u3 against rows and v1 v2 v3 v4 against columns. Okay, so we have taken v1 for column 1, v2 for column 2 and v3 for column 3 and v4 for column 4. Likewise for rows u1 u2 u3 we have taken. Okay, and here u1 plus v1 equal to 2. Okay, u1 plus v1. So for this cost value which corresponds u1 and v1, that is first row and first column. So we have this equation u1 plus v1 equal to 2. Okay, and for this value, that is 3, what is the equation? u1 plus v2 equal to 3. Okay, and for this number u2 plus v4 equal to 1. Okay, and for this number u3 plus v1 equal to 5. Okay, and for this number u3 plus v3 equal to 15. Okay, and for this number u3 plus v4 equal to 9. Okay, so using the cost values of allocated cells we have formed these equations. Okay, which is step 3. And what is step 4? Finding the values of ui and vj's. Okay, first of all we have to take v1 equal to 0. Okay, so by substituting v1 equal to 0 we will get u1 equal to 2. Okay, and substituting u1 equal to 2 in this equation we will get 2 plus v2 equal to 3, which implies v2 equal to 1. Okay, and next here here we are having v1. Okay, so substituting 0 here, we will get u3 plus 0 equal to 5, which implies u3 equal to 0. Okay, and u3 equal to 5, 5 plus v3 equal to 15, which implies v3 equal to 10. That is 5 plus v3. By adding 10 to this number, we will get 15. Okay, so v3 equal to 10. And u3 equal to 5 plus v4 equal to 9. Okay, so which implies v4 equal to 4. And here, substituting v4 equal to 4, we will get u2 equal to minus 3. Okay, so here we have got the values for all the variables. Okay, and here we have substituted all the values, right? And for empty cells, we have to find the summation of u and v. Okay, so this is an empty place, so here we are going to find the value, and this is also an empty place, so here we are finding the value, right? Here u1 equal to 2 and v3 equal to 10, so 2 plus 10 equal to 12. Okay, likewise here u1 equal to 2 and v4 equal to 4, so 4 plus 2 equal to 6. And likewise minus 2 plus 0 equal to minus 3. Minus 3 plus 1 equal to minus 2. Minus 3 plus 10 equal to 7. And 5 plus 1 equal to 6. Okay, so for this cell, we are taking the row value and the column value, and adding these two, we will get the number. Okay, and for these cells, we have to take the cost values. Okay, so we have taken the cost value for these cells. Okay, and we are going to find the cell evaluations by subtracting cost minus ui plus vj. This is our ui plus vj, and we are going to subtract this number from the cost value. Okay, so here these are all allocated cells. For empty cells, we have found this number ui plus vj, and for these cells we are going to subtract 11 minus 12. Okay, ui plus vj value we are subtracting from this number. Okay, 11 minus 12 equal to minus 1. 7 minus 6 equal to 1. Likewise 1 minus of minus 3 equal to 4. Okay, minus into minus will become plus, so we will get 4. And 0 minus of minus 2, which is 0 plus 2, so 2. And 6 minus 7 equal to minus 1, and here 8 minus 6 equal to 2. Okay, so this is our values, that is cell evaluations. This is our cell evaluations, and we have to check the signs of cell evaluations. Okay, so here we have two negative values. If all values are positive, our current solution is optimal solution. Here we are having two negative numbers, so that we have to form the loop and follow the next step. Okay, so here two negative values we are having, but both negatives are same numbers. Okay, if we have two different negative numbers, then we have to take the most negative number. Okay, here the two values are minus 1, so we can take either of them. I am going to take this number. Okay, that means here we are going to start our loop. Okay, a loop is nothing but a straight line, vertical line and horizontal line, which can start from this cell. Okay, which can start from this cell and has to end at any of these vacant cells. Okay, it cannot end at this cell, it has to end at the empty cell. Okay, so here I am going to start our loop. If I draw the line here, then I can go like this, here or this way. Okay, so if I go here, and I can draw like this also. Okay, if I draw like this, here it is not possible, because here this is not an empty cell. Okay, only to the empty cell we can stop that loop. Okay, we can stop that corner. Here if we draw like this, then I have to come back to this vertical line, but here these two are not empty cells. Okay, hence this is not possible. Okay, so if I start from this place I can draw this vertical line. Okay, and if I go here, then which line I can use? Horizontal and vertical lines. So if I use vertical line, and it will go here. Okay, so it is not an empty cell, so this line is not possible, and hence this loop is impossible. Okay, so I have only one way to draw loop from this cell. Okay, it can go here because this is an empty cell. Okay, and from here I can draw to this cell because this is also an empty cell. Okay, then I have to come back to our starting place. Okay, this is our loop. For a loop we have to use horizontal and vertical lines. It can start from this cell, okay, which has most negative cell evaluation, and other corners must be on the empty cells like this. Okay, for the loop, only one corner will have most negative cell evaluation and other corners will not have any values. Okay, so this is our loop. For this loop, from this is our starting place. So here we are going to put plus sign. Okay, and next corner I will put negative sign, and other corner positive sign, and other corner negative sign. Alternatively, I am putting sign, and this is our starting place. So I am putting plus sign here. Okay, positive sign for the starting place, and negative sign, positive sign, alternatively I am putting. Okay, and I have taken the allocations in our original table. Okay, we have started from this allocation, so I have taken our original allocation. Okay, and for these minus places I am having two negative signs. Okay, one is here and another one is in this corner. Okay, and in these two places I am having 1 and 3. Okay, in these two numbers 1 is the minimum. Okay, so this 1 I am going to add and subtract to the corners of the loop. Okay, clear? So here this is our starting place. So I am putting positive sign, and next corner I will put negative sign, and to the next corner I will put the alternative sign. So positive, and next corner I will put my negative sign. Okay, so alternative sign. Okay, and for these two places I am having negative signs. Okay, this one and this one. In these two numbers with negative sign I will take the minimum number, and I am going to add and subtract this number to all the corners. Okay, here I am having positive sign, so I am adding 1, and here I am having negative sign, so I have to subtract this one from the allocation. Okay, and here I am having positive sign, so I am going to add these two numbers, and here I am having negative sign, so I will subtract these two numbers. Okay, so here I am adding 1. Already there is no allocation here. Okay, so here I will get allocation with 1 unit, right? And for the second corner I am already having 3 units allocation, and I am subtracting 1. Okay, because I am having negative sign here, so I am subtracting this one, so I will get 2, and here I will add 1 because I am having positive sign. Okay, and here I will subtract, so 1 minus 1 becomes 0, so that means there is no allocation. This allocation will become 0. Okay, so that's why this allocation will leave, right? So this is our new allocation. Okay, so this new allocation we have to check for optimality, right? So here this is our new allocation. For this new allocation we find cost value, and here we have got the cost of 101 rupees, right? So our optimal procedure will give us 101 rupees, 1 rupees less than our previous answer. Okay, so this is optimality. We move on to optimal solutions. Okay, for each step the cost will differ. Okay, for this new allocation we again have to check the steps. Okay, what are all the steps? First one, this is already we have checked, so here we have 6 allocations and m plus n minus 1 equal to 6, so this is our non-degenerate solution. And what is next step? Forming cost matrix for allocated cells. So here we have allocated these values. For allocated cells we have taken the cost. Okay, so these are all here. in previous step we have allocation here, and our procedure will change our allocation to this cell. Okay, so we have to find the equations. For this number, u1 plus v2 equal to 3, and for this number u1 plus v3 equal to 11, and for this number u2 plus v4 equal to 1, and u3 plus v1 equal to 5, u3 plus v3 equal to 15, right? u3, v3 and 15, and u3 plus v4 equal to 9. This is our equation. Using this equation and v1 equal to 0, we will get the values of u and v's. Okay, so here we are having v1, so substituting v1 we will get u3 equal to 5. Okay, using u3 value we will get v3 equal to 10 and v4 equal to 4. Using u3, v3 and v4 we will get u1 equal to 1, v2 equal to 2, and v4 equal to u2 equal to minus 3. Okay, after finding the values of these variables we will substitute all the values here, and similar to the previous steps we will find the values for empty cells. Okay, for the empty cells we are finding the value. Okay, so this is an empty cell, we are finding the value. Okay, so here this is 0 and u1 equal to 1, so 1 plus 0 equal to 1, and here u1 equal to 1 and v4 equal to 4, so 1 plus 4 equal to 5. Likewise minus 2 and 0, which is minus 3, and here minus 3 and 2, which is minus 1, and here minus 3, 10, so 10 minus 3 equal to 7, and here which is 5 plus 2, which is equal to 7. Okay, and what is next step? Taking the cost of these cells. Okay, we have find the ui plus vj values here. Okay, for these cells we have taken the cost value to find cell evaluation. What is cell evaluation? Subtracting this number from this cost value. Okay, 2 minus 1 equal to 1, 7 minus 5 equal to 2, 1 minus of minus 3 equal to 4, 0 minus of minus 1 equal to 1, 6 minus 7, 8 minus 7. Okay, so here these are all the net evaluation values, but here also we are having one negative number. So here we have to start our loop. Okay, if we have more than one negative cell evaluations, we have to take the most negative one. If we have only one negative number, we have to start our loop in that place. Okay, so here we are having only one number, so this place we have to start our loop. Okay, so this way we can't draw the straight line because these are all not empty cells. Okay, and so this is the only way I can draw a horizontal line from this cell. Okay, and here I can draw this way, and here if I go to this cell, right, if I go here, then I can't go to the original place, starting place I can't go because these two are not empty cells. Okay, so that I'm having this option only. Okay, so I can draw a loop from this cell like this only. Okay, right. What is the next one? Putting positive and negative signs. This is our starting place. I have put positive and negative signs alternatively. For the starting place I will put positive sign. Okay, and I have taken the allocations in previous step. Okay, previous allocation is this one, which gives 101 rupees cost. Okay, this allocation I have taken, and I'm having negative signs in two places. Okay, these two numbers. In these two numbers, one is the minimum number, so I will subtract this one from all the places. Okay, right. Here I am having positive sign, so this one will become our allocation here. Okay, and here 1 minus 1, which is equal to 0, so this allocation will be eliminated. Okay, and here 2 minus 1 equal to 1, and here 1 plus 1 equal to 2, and here 1 minus 1 equal to 0, so this allocation will eliminate. Okay, so this is our new allocation. Okay, for this allocation we have to find the cost value, which is 100 rupees. Okay, for this solution also we have to check for optimality, right? Again we have to repeat from step 1 to step 5. Okay, so here m plus n minus 1 equal to number of allocations, and we will take only the cost matrix for allocated cells. Okay, so here we have taken u1, u2, u3 and v1, v2, v3, v4 against the rows and columns, and u1 plus v2 equal to 3, u2 plus v3 equal to 11. Likewise we will form our equations, right? Similar procedure, and taking v1 equal to 0 and solving all these equations, we will get the values of all the variables. Okay, and substituting all the variables here and finding the summations for empty cells, right? For empty cells we are finding the summation, and for this cell we have to add u1 and v1, right? So u1 and v1 we are adding, the summation is equal to 1, and here adding u1 and v4, the summation is 5. Minus 4, 0 equal to minus 4. Minus 4, 2 equal to minus 2. Minus 4 plus 4 equal to 0. 5, 2, 5 plus 2 equal to 7. Okay, and now we will take cost of these cells and discard these cells. Okay, because these are all allocated cells. These are all allocated cells, and for these cells we will take the cost to find the cell evaluation. How we find cell evaluation? Subtracting this number from the cost. Okay, this is nothing but ui plus vj. This value ui plus vj is nothing but this number. Okay, so for all these cells we will find cell evaluations. 1 minus of minus 4 is 5, 0 minus of minus 2 equal to 2, 1 minus 0 equal to 1, 8 minus 7 equal to 1. Okay, so this is our net evaluation for the current solution, and here all numbers are positive. This means that our current solution is optimal solution. Okay, which solution? This one. Okay, this is our new solution, and this solution will give positive net evaluations, so this is our optimal solution. So what is transportation cost for this allocation? 100 rupees. So 100 rupees is the most optimal allocation for this transportation problem. Okay, for this transportation problem 100 is the most possible value. Okay, so using this Modi method we are moving our solution to the optimal solution. Okay, so until getting all net evaluations positive we have to repeat our iterative procedures. Okay, so next video I will explain about degenerate solution, right? If you have any doubt please give in comments, I will explain, and I hope this video will clearly explain this method. Okay, thank you.